In this example, I'm going to use implicit differentiation to go ahead and find the derivative of this equation, and I'm going to be isolating the y prime, or the dy dx. And remember, each time I differentiate a y term, I need to include a y prime with it. Let's go ahead and get started. So this first term here, when I differentiate this equation term by term, looks like the product rule. So I'm going to say the derivative of the first, so 2x times the second, plus the first times the derivative of the second, so this is going to be 2y, but since I differentiated a y term, I need to include a y prime. So I'm done with that. So the derivative of negative 4x squared will be negative 8x, and the derivative of negative 9y squared will be negative 18y, but also, once again, I need to include a y prime with that because I differentiated a y term. Okay, I see y prime in a couple of places here. So I need to get this term and this term isolated together on the left side, which means the non-y prime terms need to bounce over to the other side of the equation so I can deal with those. Okay, and while we do that, let's go ahead and isolate or factor out this y prime term. So y prime, so that's going to be 2x squared y minus 18y, and that equals then 8x minus 2xy squared. Okay, well, to finish getting this y prime all by itself, I can divide both sides of my equation by 2x squared y minus 18y. So all that will cancel. So y prime looks like it'll be 8x minus 2xy squared over 2x squared y minus 18y. Well, looking at this, is there anything that's common to every single term that I can cancel? Well, x, oh, but no x here and no y here. But it does look like the coefficients are all even. So let's go ahead and factor a 2 out. So it'll make this a 4, this a 1, this a 1, and this a 9. So we can go ahead and rewrite my derivative here. So 4x minus xy squared over x squared y minus 9y. And using implicit differentiation, here's what this derivative is going to look like.